All right, here we're looking at section 6.5, and we're going to really start to be solving these exponential equations. So we always start with our learning targets, and here we can solve exponential equations with the same base, and then with unlike bases. That's where it gets a little trickier, so we're going to follow some steps. So really today all you need is this sheet that we're going to fold in, and these tabs are not totally correct, but they're still going to give us everything that we need. So I'm just going to close my notebook and we're going to work right through this. So we're going to start down here in this bottom left corner. Okay, this is kind of our most simple form. So here I see that my two bases are the same. And remember that we're dealing with an exponential equation, which means our exponent has our variable in it. So when my base is the same, I can set the exponents equal to each other. So I'm going to write myself a little note. So when bases are the same, set exponents equal. And that's the property of equality with our exponential equations. But I didn't want to go ahead and write a whole new fancy thing. This is just one thing we know, that if my bases are the same, then I can set my exponents equal. So here my bases are definitely the same, so I can go ahead and set 3x equals 2x plus 3. So now I can just solve for my x. Now to do that, I get all the x's on one side, so I subtract 2x from both sides. So I end up with x equals 3. So since my bases were the same, I just set them equal and go from there. Okay, so now let's look at what happens when my bases are not equal. So here I have 9 to the x plus 2 equals 27 to the x. So again, I see I've got different bases, so I'd have to do a couple little steps first. So first I want to come up with the base that would make them equal. Well, and I know that both 9 and 27 are powers of 3. So I'm going to rewrite both sides of my equation using that power of 3. So I know that 9 is 3 squared. So then I can go ahead and, using my properties of exponents, set it like that. So 3 squared, and there's the rest of my exponent. Okay, equals 27 I know is the same thing as 3 cubed, and there's the rest of that exponent. Well, now my bases are the same, so now I can set my exponents equal. So the first step I have to do over here is find a common base. So I'm going to give myself that little note, because that's a really important step here to do. So now that I have those common bases, I'm going to go ahead and set my exponents equal. So I have my, the one on my left side, 2 to the quantity x plus 2 equals 3x. So the first step I always do is I use my distributive property. So I go ahead and multiply this times everything. So I have 2x plus 4 equals 3x. So I want to get all of my x's to the same side. And I'm going to go ahead and move them over to the right side since this side is bigger. So I'm going to subtract 2x and subtract 2x. So I end up with 4 equals x. So I've gone ahead and I've solved for that as well. Okay, so now let's look at this top one. Okay, so now you'll see I'm dealing with a base that's a fraction. It's between 0 and 1. So I can kind of follow the same steps. So remember what happens when we have a negative exponent? That negative exponent is what switches this to a different side. Okay, so again, I want to see, can I write 64 as with a base of 4? Well, I know 4 times 4 is 16, times another 4 is 64. So 64 can be written as 4 to the third. So here I have 4 to the x plus 1 equals 1 over 4 to the third. Well, now I'm getting closer. So the first thing that I have to do is I have to move this up into the numerator. And to do that, I make the exponent negative. So now I have 4 to the x plus 1 equals 4 to the negative third. Now I have my common base again, so now I can set my exponents equal. So x plus 1 equals negative 3. So to solve for my x, I subtract 1 from both sides. And there we go. And I've got my x now. So again, when I have a fraction, I'm following the same steps. I'm always trying to find a common base first, and then I can set my exponents equal to each other. So the final thing we're really going to be looking at is an equation sort of like this, where I don't have an exponential equation or an exponential function on one side of the equal sign. So when I have something like this, I'm going to graph it using Desmos. And here's how we're going to graph it. Let me show you real quick on Desmos. Okay, so you'll see I've graphed both of my functions. This red function is my 3 to the x plus 2, which was on one side of my equal sign. The other side of my equal sign was x plus 1. So I've graphed them both on two separate lines in Desmos. And so that's really how we're going to graph it. So you graph this as one line, and you graph this as another line. So then in Desmos, we can actually touch them where they cross and come up with an answer. But for this equation, the graphs never cross. So that means there is no solution for this one. So generally, you'll have some that actually touch, and you can see them touch in Desmos, and that's where you can just click on them, and it will tell you the x value. But here, we can see on our graphs that they never actually cross, so I know that there's no solution for this one. So we've actually gone through and we've looked at all the different ways that we can solve these exponential equations. So now you're going to take your piece of paper that we just took our notes in and use this to help you with your homework that you're about to work on. And as always, come find me when you get stuck and have questions, and I'd love to work through these with you.